Welcome, everyone, to today's Veolia Water Tech Talk entitled Unlocking Potential from Wastewater at Beverage Facilities. And the goal is to talk about how we could increase sustainability through depackaging, waste, and wastewater treatment, along with green energy and water reuse. My name is TJ Willits with Veolia Water Technologies, and I'll be your moderator for today's broadcast. Just to get through some technical information and housekeeping, obviously you should be hearing me speak now. There are two methods to hear the audio for today's broadcast. Likely you're going to listen in on your computer audio, your headphone or speakers. If you have issues with that audio source, you could always switch over to the phone call and dial in using like a teleconference number and code. Everyone's microphones are automatically muted throughout today's broadcast. Also, the webinar is being recorded, and it's going to be emailed to you with a follow-up email within 24 to 48 hours after the broadcast. Now, everyone is muted, like I said, but we want to make today's broadcast as interactive as possible. So to do that, we have a question panel on the right side of your screen. It should be the GoToWebinar question panel. And anytime through the broadcast, please just go ahead and enter a question in there, just like a chat box, and we're going to queue those up, and we have some time, hopefully at the end of the broadcast, to get through as many as possible. Now, today's Veolia Water Tech Talk is part of several within our series. If you could see that QR code on the left hand of your screen there, you could scan that, take a picture of that with your phone, or you can also visit us at our website, veoliawatertech.com. We have a couple more webinars coming up. One, obviously today is the Unlocking Potential from Wastewater at Beverage Facilities. We also have another one about degassing contaminated water on April 17th, and also one related to evaporation, which you will hear a little bit about today, but it's geared mainly towards the pharma industry as well, and that's going to be on April 24th. So log on if you want to join in on any of those other future live broadcasts. Now, outside of the live broadcasts, we have several of these cataloged and archived on our website, and you can visit our website to watch those at your leisure. Now, if you're wanting to get some continuing education credit for today's broadcast, what we're going to do is send everyone who attends the live broadcast a PDF participation certificate a day or two after the live broadcast. Now, something that's fun but really important is about this survey after today's broadcast. You'll be taken immediately to a survey. If you take the survey after the broadcast, we'll enter you into a raffle for a $25 Amazon gift card. We do that just because we really enjoy the feedback on how we can make these broadcasts as beneficial to the people that attend going forward. So please take a moment. It should only take a few minutes, but it's going to improve these going forward. Now, a little bit about Veolia Water Technologies. Veolia specializes within a water and wastewater treatment space along the lines of providing projects, multiple technologies for a project, as well as single technologies or products as well related to water and wastewater treatment. And of course, we have a wide range of services that support those projects and technologies, along with a wide range of chemical solutions that we provide as a service to our clients. And we work in pretty much all industries, from industrial to municipal, and you can see some of those listed there on the screen. Now I'm excited to transition to the technical portion of today's broadcast and introduce today's panelists for our topic. Who you'll hear from first is Chris Harvey. He's the National Sales Director at Veolia Water Technologies. He has over 20 years of experience in biological wastewater treatment, 15 years of that experience in both the municipal and industrial settings. He's worked with various technologies and processes, including anaerobic treatment, activated sludge, MBR, SBR, oxidation ditch systems, and biosolids processing. Along with us today, you also hear from Ryan Johnston. She is the Large Projects Business Development Manager at Veolia Water Technologies and Solutions, and she has worked in the industrial wastewater field for more than 22 years with a focus on anaerobic and aerobic treatment systems, focusing on reuse technologies and biogas utilization. So very, very experienced people working with leading food and beverage companies with helping them with their water and wastewater needs. So at this time, I'm going to hand that webinar over to our first panelist, Chris Harvey. Chris.
Thank you, TJ. I'm really excited to be able to talk to you all today about sustainability in the beverage industry. So this is the agenda that we're going to go over today. Just an introduction to sustainability for your industry, overcoming some of the challenges, some of the solutions and services we have to offer you to be able to reduce your footprint in the beverage sector, and then how you get started with the project. So a really exciting agenda today, and I'm looking forward to going through this with you, as Ryan is as well. So Ryan.
Thanks, Chris. Let's talk about sustainability in the beverage industry and some of the key technologies that we can use here that can get us to the end goal of reuse. So with that, Chris?
Yeah, so there's growing interest in sustainable approaches in the food and beverage industry, and especially the beverage industry. So recycling water, recycling organics can really allow a company to reduce their carbon and water footprints, which is becoming more and more important today. Clients are setting really ambitious sustainability goals that can be more and more challenging to achieve as low-hanging fruit has been implemented. So hopefully today we're going to be talking about techniques and technologies that can achieve further water and carbon footprint reductions. As you can see by this graphic here, Veolia has developed a sustainability approach based upon the United Nations Sustainability Development Goals for 2030. And we've really combined three key things as three pillars of our sustainable message to our shareholders. The first one is combating pollution and accelerating ecological transformation. The second is supporting the development and commitment of employees. The third is supporting the development of territories in a responsible way. And all this goes together with making sure that we have a good return for our shareholders, and actually Veolia's employees are our largest shareholder. So we want to go through a few examples of some of the beverage industry, of some of the ambitious sustainability goals that have been set. So for example, Coca-Cola has an ambitious goal of replenishing all the water used in their products by 2030. Dairy Farmers of America is aiming to be carbon neutral and maximize water recycling. Keurig Dr Pepper aims to reduce their water use by 20% by 2025 and be net water positive by 2050. PepsiCo and Anheuser-Busch in beverage also have very aggressive water efficiency and reduction goals. Walmart for a while now has really been driving sustainability throughout their supply chain as part of their supplier sustainability assessment. And what this really means is they require suppliers to define and meet their sustainability goals, or they risk losing prime shelf space in Walmart stores. So Walmart has really been aggressive in requiring their suppliers to meet their sustainability goals. And those of us that have been involved in the beverage industry, we've come to realise that water is a key raw material in the food and beverage market, and it's becoming more and more important. In addition to sustainability goals, industry face additional constraints such as water regulations, wastewater regulations, and compliance. And we're starting to hear more and more terms like future-proofing water supplies and having a license to operate in terms of a wastewater discharge. So I think we've set the scene now for some of the sustainability challenges for the food and beverage industry. So I'll pass it back over to Ryan, who can explain how to juggle all of these constraints into a successful project and a business.
Thanks, Chris. So how do we overcome some of these sustainability challenges? What are our go-to strategies for sustainability, water and wastewater management? So what are common water management strategies that we can use to start to increase the sustainability at beverage facilities? There are multiple steps that we can take and have taken with many of our customers. We can do water mapping and audits to see if there are issues within the production facility. Certain employee training to make sure it's not a person-created issue. Water efficiency, make sure we have the maximum cycles on cooling towers and things like that. But what we're going to focus on today is water treatment, water reclamation, and water reuse. So what is the impact of the increased sustainability and the circular economy on wastewater? It is a flow down effect on the overall treatment process that customers are going to see at their different facilities. So let's look at a typical flow schematic through. We're going to have potable water come in through the production plant. Potentially, we're going to send it through a reverse osmosis system. We're going to treat the water so that it is ready for production. Certainly water for utilities, cleaning, etc. So there is the production facility. It's obviously going to send out the finished product and any waste off to recycling. And then many times there's also facility wastewater treatment or send it directly to a POTW. So what are we doing to change this circular green economy at these particular plants? So let's look. Now, instead of just treating the wastewater or just sending it to a POTW, you can produce biogas and green energy. We can look at reusing the reclaimed water back within production. And we can also look at treating high strength waste streams that maybe were sent to a landfill or things like that. We can now send them back and look at depackaging and recycling. With that, Chris, why don't we walk through, or first let's look at the impact of the increased sustainability on the economy on the wastewater. So what does that do to the overall wastewater stream? It certainly intensifies the wastewater. We can have a much higher organic loading, COD, BOD, that needs to be treated, can't simply be sent to a POTW. It's going to have increased TSS. So now we need to handle solids instead of just treating soluble wastewater. But one of the things that we're going to talk about throughout the rest of the presentation is also the increased TDS from brine handling from an RO system. So again, how do we overcome the wastewater intensification, but more importantly, unlock opportunities? We don't want the wastewater to simply be a cost for this facility. We want it to be a driver for production as well. So how do we do that? There are a number of key areas and technologies that we can utilize going forward. We're going to talk through some of the primary and depackaging, biological treatment, and then tertiary polishing followed by reuse, and finally finishing up with sludge handling and brine treatment. With that, Chris, let's talk through depackaging first.
Excellent. Thank you so much, Ryan. So yeah, Ryan mentioned landfill diversion, which is becoming more and more important for sustainability for food and beverage manufacturers. And the first process we want to talk about today is depackaging of post and pre-consumer waste. So some quick statistics for you. 30% of all waste, food that's unsold or unconsumed in the US every year, 38% of it. That's 80 million tons of food that goes to waste every year, much of which ends up in a landfill. However, on a positive note, legislation has been passed in 12 states regarding food waste that has to be diverted from landfills and encouraging them to be converted into green energy. Obviously, some of this waste is contained in food packaging, and that food packaging has to be separated from the organic material, and that's what we call depackaging. So the e-Cruiser is a technology that not only removes the organic material from the waste, but then also decontaminates the waste that's left over. So you can imagine if you have a can of tomato soup, for example, you can squeeze the soup out of the can, but then you still have some soup left on the can that needs to be removed. So this technology not only allows you to extract the organics, it also allows you to create a clean waste that can be potentially recycled. So what are the advantages of this? Obviously, you're no longer sending waste materials to landfill, so you have a reduction in tipping fees and transportation costs to that landfill. And potentially it can be converted into green energy. So you can have the advantages of a lower carbon footprint and renewable identification number, RINs, and tax credits for biogas production. So essentially the e-Cruiser technology is a puncher and squeeze process that extracts the organics from the containers that they're contained in. And that allows you to generate a rich organic stream that can be a great feedstock for anaerobic digestion that generates biogas to generate green electricity. So here you can see the main components of our depackaging e-Cruiser system. So we have grinding screws that extract and destroy the containers that the organic waste is contained in. We have a perforated screen through which the organic material gets squeezed. We have collection screws for the inert material or the packaging material that's left. And then we have an extraction screw, which includes a washing mechanism that allows you to clean the depackaged material, the waste that's left over, so that it can be recycled, whether it's plastic or metals or paper. We'll now show you a quick video of the e-Cruiser in action, and you can see how effective it is really in separating the organic material from the containers it's contained in. So now we're going to talk about one of the key steps in wastewater treatment of food and beverage industries, which is anaerobic treatment. Once again, it's treatment in the absence of oxygen that allows you to convert an organic material into biogas. So let's see how that's done. So large organic molecules, soluble and insoluble, have to be broken down through a process called hydrolysis, which really takes those organic molecule chains and chops them up into smaller chains. That can be either a biological process, a thermal process, or an enzymatic process, or a chemical process. So those smaller molecules then are further broken down through the acidification process, which is a bacterial process that generates a volatile fatty acid, which is a great feedstock for anaerobic digesters. The last step in the process is methanogenesis, or methane formation, where those volatile fatty acids are actually converted into carbon dioxide and methane, the combination of which is called biogas. And that is the biological process. So in reality, what happens? So take, for example, 1,000 pounds of COD. When you pass that through an anaerobic reactor, the majority of the energy content or the organic material of that wastewater will be converted into biogas. And that biogas is normally 65 to 75% methane, or CH4, which is obviously a great feedstock for renewable energy, both in terms of the thermal content of the material that it contains, as well as the potential to generate green electricity. Some of the wastewater is converted into biogas, a very, very small fraction, about 5%. And that obviously has to be disposed of or used in a different process. And some of the wastewater is, ends up non-treated and gets disposed of as the effluent. So normally 80 to 90% of the organic material is converted into biogas or waste sludge. So in practice, Veolia has various different technologies to treat organics, whether it's soluble waste from a soft beverage plant production, or whether it's more solid waste from a different manufacturer. So we have high rate granular systems, which are very, very good for soluble organics. We have medium rates anaerobic systems, which are good for soluble and insoluble organics. And then we have the low rate systems, which are really good for depackaged waste that have very, very high insoluble organics and solids. Additionally, we have some biogas treatments, so that mixture of methane and carbon dioxide. We have a technology that can scrub the H2S out of the biogas, which is very good for thermal use downstream of the biogas system. And then we also have a biogas upgrading system that can generate renewable natural gas that can be used as a direct replacement for natural gas in a distribution network. So the biogas that's generated, especially currently to meet the tax credits that are available through the Investment Recovery Act, or Inflation Reduction Act rather, you can burn it and recover the thermal value of the biogas in a boiler to generate hot water or steam. You can send it through a CHP or a cogen system, which gives you both electrical generation and waste heat recovery to heat a digestion system. So they're generally the most common type of process for beneficially using biogas. Additionally, you can use our processes to upgrade the biogas into a 99% methane natural gas stream, and that's called renewable natural gas, or RNG. In the future, we may see applications such as gas turbines and fuel cells that can generate electricity and also convert the methane or the biogas into hydrogen, which is obviously a green fuel of the future. So I touched briefly upon the Inflation Reduction Act, or the IRA. So there are tax credits, federally tax credits available through the IRA at the moment for biogas systems that beneficially use the biogas. So unfortunately, there is a window for projects that have to be started by the end of this year, but potentially there's a 30% tax credit for the anaerobic process that you can apply for. So that was my introduction to anaerobic treatment. Now, Ryan, you can maybe go over a few specific examples about how the tax credits work.
Yeah, thanks, Chris. Let's talk through a conventional biological wastewater treatment plant. Many times the wastewater is going to come in through screening, get equalized certainly, and then run through the high rate anaerobic digester, as you had mentioned. That anaerobic digester is going to produce the green usable biogas, and potentially you will have downstream treatment to additional biogas, additional effluent quality from an MBR, a UF, or an RO. This system is not considered a qualified biogas property because you're simply producing the biogas and flaring it and not taking advantage of using it. So if we flick ahead to the next slide, we can talk about how the plant looks, how it looks a little bit different and how we can utilize that. So overall, if you look at this particular system, the investment breakdown, the core wastewater treatment equipment, about $9 million, give or take. Again, zero tax credit because you're not utilizing the biogas. So the total investment of the wastewater treatment plant, and can look like a cost, is $9 million. If we tweak it and make it more of a renewable biological treatment system, let's click ahead so we can get those investment breakdowns. And how is the plant different? So instead of simply just flaring the biogas, now we're going to clean and store the gas and use it in one of the multiple technologies that Chris recently mentioned, the CHP, a boiler, or for renewable natural gas generation. So how does this look different? There is additional capital cost. Let's break down the investment. So the core wastewater treatment, as we had mentioned previously, was approximately $9 million. The biogas equipment, depending on the complexity, the H2S content, and the end gas quality that you're looking for, is anywhere from $1 to $3 million additional estimated CapEx. But on top of that, when you take a look at the tax credit, you're now looking at between $1 and $4 million of IRA tax incentive. So your cost goes from $9 million plus 3, giving us $12 million for the total project. But now you're looking at a $4 million tax incentive coming back. Certainly there's other benefits on top of that that don't just affect the bottom line, the sustainability, things like that. So if we look ahead on the next slide, it's going to then show us how do we take a look at it. So initially the customer, again, between the $1 and $4 million of tax incentive, will get that in year 1. So you can see the sewer savings based on cleaning up the water. You see the energy savings from the overall biogas production from the anaerobic reactor, and you can see the annual savings that the customer is projected to have. This project has a payback of approximately 3 years, certainly goes ahead and makes the biogas portion of the project very valuable in the long run for the customer. So how do we generate that biogas? Let's talk through the different technologies and how we can get there.
So thanks, Ryan. Here's a case study of a food manufacturer that was facing increasing sewer discharge surcharges. So they made the decision to install their own wastewater treatment plant so that they could own their own future in terms of the discharge costs. So in this case, we installed a treatment system to treat about 500 to 850 gallons a minute of flow, 20,000 to 35,000 pounds of COD a day. Some solids, some FOG, and we had to meet very, very tight effluent requirements of BOD5 and TSS of less than 10, ammonia less than 5 ppm, total phosphorus less than 2. So it really was a challenging project for us to work on. So the pre-treatment process that we designed and installed, as Ryan mentioned previously, included screening and equalization tanks to balance out the flow and the load. One of our high-rate anaerobic reactors that converted the soluble organics into biogas, a 2-stage biological treatment system, an MBBR, to remove the BOD as well as nitrify the ammonia into nitrate, a DAF system, a filter and a UV to meet the discharge requirements. So the good thing about this project was that the biogas was beneficially used through a CHP system to not only generate power but also generate heat to heat the wastewater for the anaerobic system. So here you can see some of the components that were installed, the H2S scrubber, the anaerobic reactor, the CHP, and this plant now is actually fully powering their wastewater plant off the biogas that we generate from the anaerobic system. So a fantastic sustainability story, and once again, a great example of how our processes can help customers reduce their sustainable footprint. I'll now pass it over to Ryan to talk about aerobic MBRs and how they can help a client reduce their water footprint.
Thanks, Chris. So aerobic MBR is a membrane bioreactor. It's a little bit different than the anaerobic system that Chris had talked us through previously. Again, it's an excellent technology to biodegrade industrial food and beverage wastewater in particular. It can give you a stringent effluent quality and meet the standards as necessary. And then we're going to talk a little bit more as we go along about reverse osmosis and water reuse from the wastewater treatment plant. And the MBR is the perfect pre-treatment for that RO system. So if we look at the basic process, what are the pieces and parts of the aerobic MBR? We're going to have, number one, a biological reactor where the sludge can be in contact with the wastewater and break down the BOD and the COD. We're going to have membrane cassettes, our ZWeed membranes, that are going to actually filter out any of the contaminants. We have a permeate pump and air blower, a control panel, and permeate and air piping so that we can continue to filter the particular material. You can see the overall cassettes. These are standard packages that we can send out to the site, and it's easy. They're easy building blocks so that we can expand the system as needed. So as we talk through the different MBR advantages, you'll see in the next slide from footprint, there's certainly reliability because you have the final membrane barrier, so you're not sending out of spec effluent to wherever you're discharging, whether that be a river, a POTW, or downstream RO treatment equipment. So let's talk a little bit about the reverse osmosis system and how we want to create the opportunity for that high quality reclaim and reuse. If you're looking to reuse the wastewater back within production, whether it be a cooling tower, a boiler, RO is the perfect technology for that. So we would pair that with our ZWeed MBR, as we discussed, and the downstream RO system. So we've delivered more than 1,000 RO systems around the world, and it can be sized anywhere from a couple of GPM to a couple of thousand GPM with both our RO and NF element technologies. So the successful operation of an RO system is being able to provide good, consistent quality, the UF permeate to the particular RO skid. So if you take a quick look, you can see the permeate quality that we can target. Very low virus, low residual organics, low turbidity, which all are beneficial to the RO system. It'll give us membrane protection from particles and certainly biological fouling, and it will give a customer consistent feed water quality back for utilization in their production plant. So what are the important RO wastewater design parameters? We want to make sure we look at the cross flow, we want to have low flux, and we want to have bank by bank capabilities for cleaning. This allows the operator to focus on the chemical cleaning, and it's not going to force any downtime for cleaning of the system, or so that the customer continue just to focus on production. So are there any negatives of the RO? There does happen to be a challenge, and it's a challenge that many customers are now seeing in the future. So if we go to the next slide, I want to take a second and focus on TDS. Chris mentioned the anaerobic system. We talked a little bit through the aerobic MBR, the membrane bioreactor. You can see that the TDS approximately is 2,000 coming into the anaerobic. Again, 2,000 after the anaerobic into the MBR. But as you continue to walk through the gray boxes and the treatment trains, you can see that once the water goes through an RO system, you're going to have a TDS of over 8,000 because we're continuing to concentrate up that TDS stream. So what is a customer to do if there are if there are low TDS limits and they have a high TDS brine stream coming out of it? So we're going to talk just for a second through a quick case study. This particular plant is a facility out in Arizona. They had stringent water reuse qualities. Again, Arizona, arid climate, they needed to reuse some of the water. So they are actually taking their wastewater, they're treating it through the UF, aerobic MBR, and through an RO system. That RO water is going to be reclaimed at more than 92%, and that'll be used in their boiler and cooling towers. But then they had, unfortunately, to deal with the TDS from both the ingredient water ROs and the wastewater ROs. They had an effluent TDS discharge of 2,500 milligrams per liter, and they were well over 10,000 milligrams per liter in their brine stream. So the RO brine, it's approximately 50,000 gallons per day from the combined ingredient water and wastewater RO systems. That is going to be directed to a standalone brine tank, and it brought tears to the customer's eyes when they received an estimate to haul that material at more than $7 million a year. So the customer is asked to look at multiple different options and how they can go ahead and treat that particular brine stream. And with that, Chris is going to talk through a thermal option and what you can do to handle that brine.
Thank you so much, Ryan. Yeah, so as you mentioned, there's more and more regulations being put in place now, especially on the west of the country, on TDS limits of discharges for municipalities. So as we squeeze more and more water out of these systems with high recovery ROs and other systems, we are end up with a high concentrated brine stream that is very expensive, as Ryan shows, to dispose of. So one alternative is to reduce the amount of liquid to be disposed of, and thermal evaporation is definitely a great technology for that. So depending on the concentration factor, obviously you can squeeze water out of the brine system using thermal technology through evaporating the water, and that can result of a 95 to 75 to 95% recovery of water that are very, very high quality distilled water quality. So depending on the concentration factor and the materials construction, when you start concentrating up these brine streams, you can get a really, really good recovery of water and give you less water or brine that you need to dispose of. Once again, we can push that even further and add a crystallizer on the back end and really give you 99% plus water recovery should you need it. Obviously, there's a cost associated with that. So how do evaporators work? So there's various different types of technologies. You can have a low boiling temperature evaporator, which allows you to have very, very good corrosion reduction when you concentrate up the brine streams as you extract the water. You can have different ways of running it. You can have a vacuum evaporator where there's no oxygen, so that avoids any issues with pitting inside the reactor. It is a total closed loop system. There's no emissions to the atmosphere with very, very high energy recovery. And there's low energy needed because it's a very efficient process. So it gives you an operational cost reduction that really allows you to give significant savings versus that $7 million of hauling water off-site, the brine off-site, as Ryan showed previously. So now we're going to walk through a case study. So this is a case study for a brine evaporator. So the brine was generated by a reverse osmosis system. It's fed to our Evalid evaporators that extract as much water as we can. And then the brine from the evaporator is actually fed to a crystallizer system. So you're going from sort of 170 tons a day of material, mostly water and some brine, to 43 tons of concentrate that gets fed to the crystallizer, 127 tons of distilled water that can be recovered and reused back to the customer, and eventually through the crystallizer, about 10 tons of solid material that's your waste product. So this is a really, really sustainable way to squeeze as much water as you can and remove the TDS that otherwise couldn't be discharged that would be hauled off-site. So very, very sustainable solution, a 94.5% brine recovery, which is fantastic, or water recovery from the brine. So I'll now pass it over to Ryan so we can wrap up this presentation.
Thanks, Chris. So as people sit and listen, how do we get started with a particular sustainable wastewater project? What are the steps? How do we get it going? So potentially we would start with feasibility and due diligence to understand what the overall flow scheme is, what the waste is leaving the production, what the peaks and valleys of the flows are, what the flows and loads are, and most important, what the effluent goals are for the overall project. So we would then have the opportunity to develop the proper technology and the overall process design. You could certainly then walk through engineering and design, making sure it meets all the customer's goals along the way. We work to value engineer, try and meet the budgetary, certainly the schedule, and most importantly, the performance objectives of the project. Then in partnership, we would execute the project, whether it be design, build, operate, maintain, and finance. Whatever the project execution strategy is, we walk through it with the customer to meet their needs on the overall project design needs. Then the startup and performance testing of the particular plant.
So yeah, I just wanted to highlight that first column there. The defining of the design basis is probably the most important work that we do. It's really important to make sure you spend the time to make sure you have a correct design basis, or all the other subsequent steps will be incorrect. So it's really important to do due diligence there.
Appreciate that, Chris. So sustainability wastewater project checklist. Are there corporate sustainability goals? That's important. We need to understand when the project kicks off, are there certain targets that we're hitting? Are there water reuse targets that you're looking for? Is it a zero landfill customer? There are many of the different things, corporate sustainability goals that we need to walk through. Is there future expansion coming to the site? Do they need to add additional lines in the beverage production plant? Are they going from 4 to 8 lines? Are they limited by wastewater treatment capacity? So these are all the different major pieces that we're going to step through for the project checklist. Always and most importantly, to make sure that the customer can maintain compliance and not have to deal with fines or issues with the municipality. And then finally, let's talk through some of our key takeaways today. We covered an awful lot of material in a little over a half an hour. Wastewater intensification, it is happening to many of the customers that we see. There are many drivers that will impact the wastewater treatment facility, but as COD, BOD, TSS, TDS are increasing and the effluent parameters are becoming more stringent, it's very important that you understand the different technologies necessary to reach your corporate goals. There is flexibility in the wastewater facility design. We talked through just a couple of technologies here today, but there are multiple options from an anaerobic standpoint, an aerobic standpoint, and certainly a biogas utilization standpoint, as Chris walked us through. We need to utilize those trusted technologies and the processes. They have been commercialized for many years. They're ready to be utilized, and they have been installed at thousands of installations around the world. So in the meantime, we want to unlock opportunities from wastewater. We want to utilize these technologies to reduce the carbon footprint, the water footprint, and increase the overall sustainability. As mentioned on the RO case study slide, the customer out in Arizona is looking to reuse more than 92% of the overall wastewater. It is being driven by their corporate sustainability, and that plant is the factory of the future, a flagship for their particular portfolio because of the water reuse within the plant. And then most importantly, again, as Chris talked about, and we talked through the IRA tax incentive, we want to generate a reusable green biogas, and we want to use that where we can, whether that be a boiler, a CHP, or clean it up and even put it back in the pipeline. There are multiple opportunities for green biogas. With that, thank you for the opportunity, and I will pass it to TJ.
Wow, Chris and Ryan, thank you so much for sharing just so much information about the various technologies. I think the key takeaway for me is that there are tremendous and very challenging goals that manufacturers have set for themselves. But the thing that my takeaway is that it's very reassuring to hear that there are time-trusted technologies already out there with a lot of experience, a lot of references that could help them deploy their sustainable strategies at their facilities. So that's good to know. We have some questions here. Just want to remind everyone, there is that question pane on the right side of your screen. Go ahead, type that in there. We have a few already that we could start with, but we'll try to get through as many questions as possible in the time that we have left here. Okay, just a couple questions that I'm going to link together. They're relatively related, but it has to do about aerobic versus anaerobic and trying to understand what is the best way to utilize those tools, and do you use one over the other, some questions say, or is there a preference between those? So I guess I'm going to toss it to Ryan first, just to maybe comment sort of the selection process for those technologies, or maybe even the thought process or ideology of how to tackle the decisions for aerobic versus anaerobic.
Thanks, TJ. So one of the things that we like to look at is we first want to start with the customer's wastewater. So is it a very high strength wastewater? Is it a medium strength wastewater? You know, we have rules of thumb on, geez, if it's over X thousand milligrams per liter of COD, it makes a lot of sense for an anaerobic option. If it's, only needs to be polished to a certain point, it could possibly be just an aerobic option. But that's also where it's very important that we go through the customer checklist, sustainability checklist. Is water reuse an important factor? Is biogas generation an important factor? That all helps us drive which particular technology we select for a customer and why it might make the right one fit better from one customer to the next.
Can I build on that?
Yeah, please do, Chris.
I would say in today's market of sustainability and people viewing wastewater more as a resource to be extracted rather than the waste product, I see anaerobic and aerobic technologies being very, very complementary. So you squeeze as much of the organics as you can and convert that to biogas with an anaerobic system, but then polish it with an MBR RO type system to extract the water from the dissolved solid. So I think each of them has a play, and I think together it's a very, very powerful solution for a customer.
Thank you both for commenting on that. Just another question here is, what type of facility would be best suited for a true sustainable approach? Is there any rule of thumb or any kind of go-to strategy for putting that project together for a beverage manufacturer? Chris.
That's a great question, TJ. Thank you for that. So Ryan, if you don't mind, I'll just give you my thoughts and then you can add to it. So
please do.
Obviously, there's a certain size limit that you need in terms of mass of organics that you're generating in your wastewater stream for a renewable project to make sense financially in terms of payback and ROI, as Ryan showed on those slides. So generally, larger facilities that are using a larger amount of water that potentially also have some pre-consumer waste that we could extract and use as additional feedstock for a anaerobic digestion system. So certainly the soft beverage industry, the brewing industry, distillery industry, vegetable manufacturers, soup manufacturing plants, all those sort of facilities are really good, as well as other industries, such as the recycled paper industry, some chemical industries, and some other industries that are a good fit if they have a nice organic stream to generate biogas. And then also large consumers of water that are in water-constrained areas are a great fit for water reuse. And Ryan, I don't know if you want to comment on that more.
Yeah, I appreciate that, Chris. So with the effluent requirements that we can meet with the UF and the RO systems, it gives us the opportunity to recycle a lot of water through the facility as we discussed. So it's an opportunity for a customer if they don't have water rights, they're unable to get enough water for the upfront production. We can return it back in boilers, cooling towers, and we can look to reuse. And it helps the customer to push a little bit more production through that particular plant. But overall, I agree with your comment, Chris. There's many industries that the anaerobic, aerobic, thermal RO system certainly can accommodate and meet the effluent requirements. But first and foremost, and where my heart sits, is food and beverage. I know that's what we're targeting here. So, these particular processes certainly fit at any of the food and beverage applications.
And one thing that we touched on maybe is worthwhile highlighting is that an RO system can be very sensitive to biological fouling and chemical scaling. So we spend a lot of time working and developing and optimizing the MBR aerobic system to really give a cleaner water as possible, which in fact is a great feed quality for the RO that really increases its life and operating cost. So it's really important that if you are looking for a reuse level quality of basically demineralized water, that you have a really strong and robust treatment process beforehand, like a aerobic MBR that we've developed. So
going to a little bit more on the water reclamation side, there's a couple questions related to that. The first question I have for you, Ryan, is can you talk a little bit more about the case study, the design basis or process which allowed you to achieve that 90% recovery on that particular project? Is there anything that you could add to that?
Sure. So the overall flow to the wastewater treatment facility, and I should actually clarify, the owner doesn't want it called the wastewater treatment facility. They want to call it the WRC, the Water Reclamation Center. So they're sending about 265,000 gallons per day of water to the WRC. It's being treated through our aerobic system. So we have a biological reactor, screening, and then the UF system. It then flows from the UF to the RO, and the RO has been sized and designed as a double pass RO to make sure we hit that effluent quality. And then the RO reject is going to the brine tank, as we discussed. It's about 4,500 milligrams per liter of COD, so it is a high strength wastewater. So we have a retention time of solids in the MBR, so we can treat that. But the UF gives us excellent quality before it goes to the RO, before it can be reused within the plant. The customer had certain targets that were set by their cooling tower manufacturer for them to reuse in the facility. So in the design, we walked through it and we made sure that we could meet those targets that the cooling tower provider had set.
The WRC, very interesting way to spin, and shows really where the future is going for wastewater. It's not wastewater anymore. It's a very very interesting takeaway there. Following up to that, just you sort of touched on a little bit in the Arizona case study. It looks like that was going to cooling towers. Can you talk about some of, in addition to cooling towers, some of the destinations for the reclaimed water from these advanced WRCs?
Sure. So there's an opportunity for boilers as well. We also have some customers that are actually spreading it on a local golf course and using it as irrigation. There's a customer in the Caribbean who is combining it with their fertilizer stream and using it on the sugarcane. So there's a lot of different potential opportunities. And then there are customers that simply want to get the effluent quality before they send it to the POTW to drastically reduce their surcharges. So there's multiple different opportunities and different ways that we can reuse that water.
Thanks, Ryan. Jumping back to the anaerobic technologies there, this particular question mentions that there were 3 different categories of anaerobic treatment systems, low rate, medium rate, high rate. Can you talk a little bit about what are sort of the parameters around what solution you would pick for any given application? Can you talk about that, Chris?
Yeah, that's a great question. And we could probably cover a whole hour on that topic. But to summarize, the high rate granular systems are very good for soluble organics, such as soft beverage manufacturers, sugary wastewaters, because there's no hydrolysis that occurs in those reactors. So it's simply acidification and methane formation. So it has to be a relatively simple substrate in the wastewater that then gets converted into biogas. If you have a more complex wastewater with some amino acids and proteins, fats, oil and greases and suspended solids, we can either remove them prior to a high rate granular system, or we can digest them in a more of a medium or a low rate system. So production plant wastewaters that have solids are amenable to those medium rate systems. If you truly have a pre and post consumer waste depackaged material that's a standalone, that would be more of a low rate system because it is so highly charged in organics. And we have experience with systems treating up to 150, 200,000 ppm of COD. So we do have a lot of experience not only in the high rate systems, but also the medium and the low rate as well. So it really depends on the applications. And then once again, if you do the digestion with the medium and the low rate systems, you often have a digestate liquid stream after that contains quite a lot of phosphorus and nitrogen. And Veolia is a company where we're dedicated to sustainability. So we're really looking at technologies that can not only treat that nitrogen and phosphorus, but also recover it or produce less N2O emissions, for example. So we're really at the forefront of sustainability, once again, in converting wastewater into a resource rather than the waste material. Did that answer the question, TJ?
Absolutely, absolutely.
Thank you.
And similar to this, not so much about a technology question, but more about a tax incentive question. You mentioned about the Inflation Reduction Act. Can you talk a little bit about the saving percentages of the qualified biogas property and what that might return for the CapEx for a project? Can you highlight that, Chris?
Absolutely. There's a base credit and then a multiplier, and the multiplier is significant. can get you up to 30% overall tax credit on the investment of the anaerobic facility in the biogas system. But that does require that the system generates either less than 3.4 million BTUs an hour of energy content of the biogas if you're burning it for the thermal content, or generates less than 1 megawatt electrical through a CHP or other electrical generating device. So we recommend that you work with a tax consultant to work through that. But the more important thing is because biogas is seen more of a transition fuel by the government rather than end state for a low carbon economy, the tax credits do actually end the application of them at the end of this year. So if you can meet the requirements of a 5% safe harbor or some other construction milestones, that will allow you to apply for the tax credit. Then you can carry 3 years backwards and 21 years into the future. So you have to meet the requirements this year, but you can take advantage of the credits for a significant time into the future. And because it is a tax credit, it's not funds appropriated by Congress, so it does exist. So we recommend that if you're interested in that, either consult us or consult a tax consultant, because there are some nuances in how the tax credit is implemented by the IRS.
And Chris, when you mentioned things like this year and timeline and deadlines, can you expound upon that a little bit of what needs to be done in 2024 to be currently, as the legislation is written, to qualify for IRA tax credits? Absolutely.
So by the end of December 2024, you have to have spent 5% of your project budget, overall project budget, and that's called a safe harbor requirement. Based upon our interpretation, and once again, we're not tax experts, of prior tax credits, and this is based upon a wind farm, for example. The example was that if you've begun construction of the foundation of the wind turbine, that allows you to apply for the tax credit if you've completed that activity before the end of the year, or if you've begun construction of the wind turbine off-site before the end of the year. So if you correlate that back to a biogas system, that means that if you've begun excavation for the foundations for the anaerobic system for your project, or have begun construction of the anaerobic reactor if that reactor's constructed off-site, that should allow you to meet the deadlines by the end of the year for the tax credit.
Great.
I hope that answers the question.
For sure. One other question. It's a high-reaching question. I'll ask for Ryan. But has there been any discussion related to reusing water back into the product? Ryan, I know that this is probably high-reaching for sure. Do you have any comments on any discussions with clients about reclamation going back into product for potable standards?
It is a tough one, TJ. I would lie if I didn't tell you. I think we talked to every single customer about it and the potential of it. I had a meeting just last week where the customer wanted to know if they thought they could get away with putting it in their product in the next couple of years. That is a customer-driven, a regulator-driven requirement. It's not something that, we can meet the quality that they are asking with different technologies, but that is going to come down to owner and regulatory-driven on whether they would go ahead and use that in processes or not.
Yeah, I'd say it's not a technology challenge, it's a perception challenge.
Correct.
Well said by both of you. Very good. Well, that's it for our questions. If you have a question that maybe you were shy to ask, or if it pops into your mind there, you can take down my contact information. It's up there on the screen there, and we'll get you connected to the right technologist to get that question answered. I really am very thankful for both Ryan and Chris to spend all the time preparing the presentation and sharing their experiences from the clients that they've helped, from wastewater treatment to water reclamation, water reuse, by all the technologies that you learned a little bit about here today. So I'm thankful for both of them for their time. Just a reminder, please take that survey at the end of the webinar. I really appreciate that. We'll get you loaded up for the raffle to win that Amazon gift card. And again, my last bit of thank you is to everyone here that spent a little bit of time out of their day to learn about how being more sustainable at a beverage facility and the importance of that, and the fact that technologies do exist to help clients go ahead and become a more sustainable facility that really help the entire world with the various environmental challenges that we all face. So yeah, thanks for joining us for your time here today and spending a little bit of your day with us. Be on the lookout for future webinar broadcasts. We're looking forward to share additional programming with you, and it'll be delivered via your email. And again, if you have any questions, please never hesitate to reach out. So I want to wish you all a wonderful day, and we'll see you next time. Take care.